Welcome back to our Scala to Spark class, and we will finish chapter 5 of our Spark's definitive guide book, talking about the basic operations such as limit, and then we will move on to more deeper look at working at the data types from chapter 6. That's the plan. So I will be using the same book. We use same object for the file which we used on day 22 because it's the same dataset. On chapter 6 we move on to different dataset. So limits, of course, we already know from SQL limits. So I won't. I'll just show it. Of course, why would you want to do it? Why would you want to have a limit? Well, if you're showing things, of course, it won't really make much difference, right? So limit here would not, if you're going to show 5 results, so you could have used show 5, right? Again, maybe earlier you just limit it quicker, right? So this will show first, right? So only 5 results will be shown, right? However, let's take a look if it works, right? And let's see while it's running. Remember again that most things you can write in a regular SQL syntax. So that's one of those takeaways you should take. And again, if you something you can't get the Spark commands don't work properly, you can just settle for the SQL. So what do you need, right? So limit 5, right? It worked. Looks like it worked. Okay, right? That's our limit on the top 5 rows, right? Only showing top 5 rows, right? Again. So here, right? So by default also it says it's 5, right? Let me check. 5 was 5. Actually it's all right here. So let me see here. Only showing top 5. Only showing top 5. Actually looks like it's actually the limit here. It's not 20. It's actually only shows 5 by default. It looks like, certainly looks like that way. Okay, but we have a limit, and also we had this order by. Remember from a couple days ago. Actually it was yesterday, right? Count descending. How could we do this in SQL syntax? Well, right, we can do it. Remember, most Spark commands can be on operations can be done using just SQL syntax, right? Completely, right? So all you need to do is to create a temporary view, right? So on performance there should be no performance penalty. So actually again, so in order this here, right, it should be the command order select all order by count descending, right? That would be the command. So see if you can do this, right? So we can create we need a table, right? We need to create a table, df. We haven't been doing this, so create replace temporary view, right? And we'll just call it df table, right? Nothing to it. Of course, need to create it df table, right? Then we can use, remember, we can use the SQL syntax, right? And then we can do this basically df SQL, right? Let's look at our earlier commands, right? We can in fact use the regular SQL syntax, right? Which we often will be slightly easier, right? I hope you agree with that. And we can select, right? Let's see, can we do this like with expression and using with SQL? And I think so we can, yes. So so df, not df, but we can do this. So what's our Spark, right? Is Spark, right? Yeah, Spark. Yeah, Spark. We have Spark, right? SQL, right? And then select. So again, why wouldn't you do this all the time? Well, it depends how comfortable you are with SQL itself, right? The big difference is that you often in this Spark method you have some assistance. Here you have to figure out it yourself, but it should work, right? Select from df table, right? And order by, right? Let me see here, right, order by count, right, count descending, right. You can do, of course, limit here also, right, and then show 5 or something, right, show 5, right. Okay, so this is Spark, not df but Spark, so we could do this with SQL syntax. So these commands, this command here, right, that's what we are doing here. Let's run it. And also at the same time we could do, of course, this, right, Spark SQL. What do we do? Select all from df table, and let's say limit 3, so we can see this, right, it actually works, limit 3, right, and show, right, we can show 5, but it won't show 5 because only 3 should be shown, right, because we are limiting 3 by ourselves, right, again. So if you create this view, again, this is naked, so this is required, this temp view is required to run SQL command syntax, Spark SQL, right. So again, this might be option if you are overwhelmed, which I'm sure it's possible. There's so many commands, it's impossible to remember them, right. You can practice your SQL, which will be useful even if you're not using Spark. To use this SQL might be a more pragmatic approach, but again, it's good to see different approaches in any case. So again, there should be almost always an SQL analog. Okay, so let's run it, and then we should be almost done for this chapter. Again, so those who are saying, okay, this is too much, right, don't worry about it, right, again, you can get really far in data analysis. It's just SQL, because it will work almost, the principles again are applied to pretty much many systems. Okay, let's see if any problems, but of course if I make a mistake somewhere, right, okay, no mistakes, looks like it worked. I got 3, right, I got 3, yeah, I got 5, right, so it looks so good, right, so 5 here, right, and 3 here. So yes, so notice here, if you have more than 5, it shows top 5, right, it mentions it, like you're doing the show, right, again, show is just for actually, well, for show, right, for printing out results. It mentions there's more results than 5. Again, why doesn't tell you how many are there? Because it's possible it doesn't even know how many are there. If you have a huge cluster of data, it might not be possible to do it until you actually get all the data. So here you got 3, so that's limit, right? So very simple, right? Nothing too crazy. But of course this method is also not very hard, right? Returns, and again, you can check the documentation if it's built in. You can see it's not that hard. Okay, moving on. Let's finish this. So repartition, right? So this is, remember, we have multiple partitions. So this is optimization opportunities. You can check first of all how many partitions, right? And shuffle means data will be moved around, right? That's why we have these occasional errors in our data storage actually here, right? Which would need to be had to take a look what's going on with our Windows machine, because of course this data is not really meant to be stored on a Windows machine. It's usually on Linux, right? So we can see how many partitions we have. Print line partitions, right? We have partition count, right? Right, and we will put this here, right? df. It should be, I think, 1 or 5. I forgot if I changed. I think I changed somewhere here, right? So we can check, right? And then we can change it, right? We can change it. We can repartition to 5 and so on, right? We can also, so this one of those optimizations was to repartition by specific column name. So in fact, this is one of those ideas. We tried this before. It didn't really help with our sampling, right? So this is one of those things, right? And we can repartition, say on, so it's kind of like indexing, right? So kind of like indexing, right? But actually re-indexing. It's not really, it's more like a, well, more like re-indexing the primary index, basically, right? Some optimizations, right? So that's a possibility, right? And we'll check how many we have now. We should probably have 5 now, right? We should have 5, right? So again, we are jumping into deeper technical issues here, but and there's also coalesce. So coalesce, means it will not be a full shuffle, so that might be more optimized. But let's do this regular repetition first, see if it worked, right? See if any problems, because our file system, again, it's not handling very well this these shuffles. Again, so that would be how to look actually Hadoop, right? Let's see here. Yeah, okay, it's only 5. It's still 5. That's very interesting. So it actually did not change. 5 coalesce. So why didn't do it? Well, let's see. Did we did repetition, right? Interestingly, it still gets 5. Where did we get? Where is 1? Because we did it at some point. So what I'm suspecting, right? Where is our partition count? Remember, we did 5 before. Let me get rid of this. Show partition. Yeah, here we go. Now there is 1, right? We already did this one single partition df, right? We did it here already, right? This was a their set of rows, right? So we did repetition here, by the way, already. And so, do we have any more partitions? Let's take a look. 20 times, right? For example, we did this. Okay, did this. And maybe we need to save it actually. Maybe we need to, because this repetition actually returns a new data set. So, right, so it actually returns a new one, right? So this would be, let's take a look, a new val, new df. Would it be back to 5? I think it would be. If one part, single part, yeah. And let's see how many partitions are here. Let's take a look at that. So it looks like it certainly doesn't change. New single, yeah, not very. F single, maybe. Okay, not a good name, but okay, let's run it. It should be 5. It should be 1. No, 5. Sorry, it should be 5. But let's see. Or it's going to be all 1. Yeah, 5. Okay, yeah, okay. So there's no magic. Basically, it's not in place. So basically, when you do a repetition, of course, here we got a new data set here already. This new data frame here already. 5 partitions. Okay, all right. So again, of course, on a larger, on a bigger actual real deployment, you have multiple hundreds of partitions. Okay, so coalesce was is basically optimization. It will not be. Won't have full shuffle, so you could do this, right? So let's take a look. So this will probably most likely, let's stay to 10. Well, df coalesced 5, right? Let's do something like this, right? Or maybe let's do 10, so we can for sure know this is actually different. Not coalesce, yeah. So repetition, but then we do 2. Let's do 2, right? So this is 2. Right, so should have 2, right? Right, and then of course we could take this, right? We could see how many are we here, right? And you again, why would you want to do this again? If you have a single machine, of course, this all extra work for nothing. Basically, you could just stick with single machine again, with a single machine. There is not much point in partitions, right? This is meant for actual deployments over multiple machines, right? Again, so but again, so we'll check, right? Let's see if we have the number of partitions here. Should be 2, right? Should be 2, and this should be still 1. Let's take a look, right? Because we had 10, but of course we didn't save it here. So coalesce actually down to, so coalesce, let's read it again, the documentation, returns new data set with exactly number of partitions, right? If you're doing, like we can't, okay, so it's similar, so if you go up, it will stay at the current number. So it's a new data set. It has, so basically coalesce is for merging, basically, right? You can go up, basically, apparently. So also you need repetition. So that looks like documentation is what it says. Okay, let's take a look. And finally, since I want to save time, since we have so much material to cover, I'm also going to add the end of the chapter, collecting, which is of course right. So again, you try to avoid this as much as possible. And finally, right. So there is a state of cluster in a driver, right? So sometimes you want to get data directly inside your machine, right? Of course, here again, in our machines we have the data already locally, but we, it's sitting on Hadoop somewhere, which is sort of separate system, right? We want to get it inside our application, right? So there are a couple. So data frame will get everything. So there's three things. So collect gets all the data from the entire data frame, takes like the first rows. And show, of course, prints. Show is basically prints. So these all get the data from the, from this some remote place, right? So we know, of course, this. So this is limit, right? Collect df, right? Take 5, right? And show 5. Yeah, right. And what? By the way, let's take a look. Right. Right, so these are all approaches we can take. We already have taken these, right? So we already know. So important point is that this here is yet not. We don't have data locally yet here. We do not have the data locally here. This is just an instruction, right? Also the getting gets so truncate, right? Yeah. So truncate false was yes. So this is an extra option, by the way, for long strings. So truncate false is for extra long option for truncate strings. So of course these are. Let's see. So let's take valid df5, right? This is what? Array of rows. Actually, array of rows. Actually, so this is actually. So this is actually. Array of rows or row 5, right? Arrow 5, right? So again, just to show you that it's actually array of rows. So this show, of course, is unit. Actually, no, show here returns unit. It returns, so this actually prints, right? This prints, right? However, this also prints, and keeps long strings inside cells for show, right? Is you truncate false, and this of course is also take an, I think also array row 10, right? Sorry, it should be array row 10. I'll call array row 10 because you're collecting everything, right? So you can use collect or take, right? So what's the difference between take? Takes first, collect, well, all rows, right? So collect. Right, so collect is heavier, right? So you have no option. So this is for everything. If you know, of course, if you know you have 100 numbers, right? So of course, if you know the count, you could use take, right? So again, both of these have warnings that you can get then out of memory error, right? So, right. So again, like this, right? You get a nice little help here. Yeah. Okay. So. This I showed you also how you can get help if you want to get out of this IntelliJ, right? So take or collect, right? Take if you want to have a first night, right? Again, a warning that this is not safe, right? Right. Okay. So we should be good. Of course, again, this is an array of rows, right? Yes, array of rows. So these are just regular Scala operations, and we can always print, right? So we can always print now. Now we don't have to do anything. We have the data locally. We can do now that we have data locally. We can do whatever we want using standard Scala code, right? So no Spark methods. Well, of course, we have the row access, right? Of course, again we saw. So you can, of course, again. So R row 5 for each print line, for example, right? And of course R row 10 for each print line. I'm just doing quickly, but of course you could do something else, right? So print line, I'll take all 10. Okay, so let's run it so we can finish this chapter. Hopefully no errors. No red so far. So far so good, except there's some reshuffling problem. Looks like we got something. Deleting some directory. Again, so this caching, you see, there are blocks, right? Something was not deleted. There's temporary storage, which couldn't, these rearrangements, somehow something didn't work with this cleanup. Right. And I suspect it also has to do with this extra first warning. There's some permissions issue. Right. So, okay. Again, this is might be causing sometimes some errors. Okay, so United States, St. Martin, right? So this worked, right? And this also worked. Again, so if you need your data locally, right? And again, remember you can use regular access to get, say, first element. You can get, I think, get, right? You can get using get methods. Okay, so we have the rows. Now I think we can. It's good time we can commit this. Finishing basic operations. Day 23. Limit collect repartition collect operations. Oh, I need files. Here. And now we can hopefully move on to, well, a slightly deeper look at things. So, right. So we'll look at these some of the concepts. We have the basic concepts right now. We'll look at some. Well, dealing with different types of data, right? Booleans, strings, datetimes. What do with null types, which might be messy, and complex types, even complex types. So, where do we look for the information? Again, this book is 4 years old, so again, it's impossible to see all the information, so there could be new methods. So remember data frame, right? So you need to look at dataset methods actually, right? So so that's where you would look for regular dataset methods. So whatever works with dataset will work on data frame, because data frame again is just a very specific dataset. So whatever is meant for dataset will work on a data frame. But there are some extra methods such as data frame stat functions and data frame NA functions. What's NA function? Not a number, right? Not available number, right? No. Not applicable, right? So when you have something which doesn't exist, right, null values, they are specific functions like this. These are sub-modules, right? So where do we find them? Well, there's, I'm looking at the latest one, 3.3, which is what we are using, right? Dataset, and you have a nice documentation. So again, let's open up or make a new file. We're gonna make a file day 23, new Scala class object day 23. And we'll call it different data types, right? Something like this. Extends up, add, and different documentation for data set which applies to data frame as well. Methods, right, and properties of course as well, right? So that's where you would look. That's latest, right? So you look there and you just go through. So again, as you can notice, if you remember your previous assignments from last course, right, this is just regular Scala docs. So they put on their pants just like you do, basically. As the joke goes, basically everybody is same here, right, using the same tools. They people who wrote Spark, right, they were using Scala doc too, right? There's nothing completely special. That all documentation is done through Scala doc. Okay, so and they also have some nice, actually, it has some nice examples already. So you can go through here. There's data frame functions, stat functions, NA functions. You see some extra, for example, we'll see some stat functions, for example, quantity, Bloom filters, some nice stuff, correlations, sampling. Again, we saw some samples things, right? I think here, right? Sample by, actually, this different sample, right? So yes, so that's how you find documentation. If you can't, official documentation, of course, right? There, of course, there's also places for unofficial documentation. So let's move on to. So that's so there are column methods also. We saw it's also in column methods here. There's of course SQL functions, separate place, right? So again, but most of these functions, again, they're not specifically, I mean, they are special Spark implementations, but the idea is across pretty much all analytics. If you ever, I mean, if it happens you have an assignment, you're not using Spark, but you'll have using some other engine, I don't know which one it could be, maybe just a regular database. Of course, these principles will be the same, right? Or order by, aggregate functions, statistics functions, they will stay the same as you, right? So, right, the idea is to transform rows of data in one format from structure to another, right? Maybe reduce the number of rows, right? So we will use a different, for this chapter, we will use a different data set. I think we have it, CSV, right? In first schema, we will go back to our retail data. Oh, we'll use single months, by the way. We'll use single months, maybe we'll try different months, right? So again, do not despair if there's so much, because Spark it's like many modern libraries, it's so huge, you're not expected to know it all, right? It's impossible to remember. The main thing, what I want you to in this course, is to have the principles, again, of this data aggregation, of filtering, of producing the statistics, of what we do when working with data, what to do with missing data, and so on. All the principles are more important than specific instructions, which you can always look up in documentation, right? Or, you know, of course, you can look up through Google. Googling, of course, is extremely important in this day and age. Okay, so let's read the data. Of course, I need a Spark, right? I need Spark, so we'll need that. Again, we'll need our context, right? Let's run it. Right. I'm not going to do case sensitive, that is just an option. I'm going to keep that, so I'm not going to do that anymore. I think case insensitive is fine. So chapter name is working with different types of data. Right. Okay, let's run it, see if everything works, and then we should be in a good shape. Two rows. Okay, 5 partitions, okay, you know, 3.3. All right. Now, let's see. I wonder actually, you know, I'm going to see if maybe we have less errors if I go to one partition, since we are not really, I'm just going to say one, right? Since we don't really need any more partitions, we don't need any shuffling, all the fancy stuff. It's you know, it's basically no need to emulate it if it's just if we are not using it, right? So let's do it. Let's do it once more time. So, yeah, no, of course, this error still is there, but one partition, okay, one partitions, right, okay, we could have used nice little code, right, so, we have the APIs, so, we want to read some data. So, what we'll do is, again, so in this example, we'll also use a table, right, again, this name is not specific, we'll have a temporary view, so we can use the SQL commands, which might be nice. So, let's see. Of course, our location, right? Location, file location. Well, file path will be, of course, as we remember, this is source by, not this one, but source resources, not here, yeah. Retail data, resources, source, resources. Yeah, like this, yeah. on. So I'll do file path here. Where is it? Here, right? Yeah. Yep. That looks okay. Yeah, path. It's file path. So load input is in a data frame for data source that require a file path. Let's show schema. And again, always good start. So a good starting point. And these are useful to start our operations with, to have see schema and have temp view ready for plain SQL commands, right? Okay, let's run this, see if this everything works. Let's again sanity check. So by the way, while we load, we can check our data, see what's in there. If it's not large enough, if it's locally available, of course, we might want to take a peek. Right? Okay, so we have quite a bit of things. So what do we have? We're using infer schema, right? So we let Spark determine schema, right? So what's going to be there? Nullable strings. So everything is nullable, right? So notice everything is everything is nullable. Possibly data might be missing, right? And that's important point. We have double integer. So double integer. And so again, it's unit price customer ID. For some reason, it thinks customer ID is a, I don't know why, but let's take a look. If it's by day, yeah, by day by day. Let's take a look at this, right? The small one. Check close 22, 20, right? And what's the customer ID was the one which was country was okay. Oh yes, for some reason customer ID has 0.0, right? Okay, well yes. How about the date, right? Unfortunately, date is just no, date is fine. It's a timestamp. That's good news. So it figure out the timestamp. Again, notice timestamp is year, month, day, and then all of these options. So that's on the hour, minute, second, right? So which is good because we'll be able to use sorting methods, right? The regular sorting will work. Okay, so these are purchases from United Kingdom, right? Purchase set, and let's take a look, right? Let's take a look, and let's see. So that's already. So we have schema, good. So now we can see. So what we'll do is convert some native types to Spark types, right? So lit, right? So we can get data in the what should I say? Literal, right, function. We can convert it to or its Spark representation, right? Because of course in select we can do it directly, right? So what will happen here if I do this, right? Well, let's take a look. Of course, we'll have to import it, right? So, all right, so this will be useful. Corresponding, you see again, corresponding, there's typos here. Again, this book is good, but it's not perfect. Again, nothing is perfect. So again, so notice here we will use it like this. So what is this going to be? Select. What's happening here? Import function lit, right? Import function lit. So far only one function. So what will happen? Of course, this is going to be show. We need show because it's going to be like just like what do you see? Spark show Spark SQL, right? And we can use this, right? This is also completely normal, right? So since we can do it like this, right? Of course, only difference I'll need to use how should I do it? I could do it, I think I can use these quotes, or maybe I can use single quotes. I can use single quotes, I think, yeah, for strings, because this is after all SQL, right? So this should work, right? And show again, right? Show again, right? Because I'm not saving this result. This is single, so kind of boring, right? But let's take a look, right? So there's no need for SQL, right? Literals. Okay, and let's take a look. See what happens. So we're not selecting any other columns, right? Again, there's no original. So this is not, we're not using the data in data frame itself, right? We're just using to select some new values, basically. Let's take a look at what's happening here. Yeah, so completely right. So this showed, oh right, so there's a slight difference, right? So this showed only top 20 rows, right? So what happened is basically, so all rows got these 3 new columns, right? So interesting enough, this only shows 2. Why does it only show 2, right? So these columns, notice also how, so what I could do, of course, if you don't trust me on this, right, I can do call, right, I could do this, destination, country, was origin, I keep basic, what's the name of it? Oh no, of course, no, we don't have that, we have, sorry, we don't have, we are back to different data sets, so let's not even use that. We're gonna use it, right, you can use, let's say, description. Let's say description, right? So we can use to call description. Right, so I need to import this, of course. I need to import this. Right? I'll show only like say 4, right? Because you don't need to show so much, and I'll say 6. Let's say that. So again, so how we do it? Select 5. We can do description, right? Description. Only things here I don't say from df table, right? From, you know, because I don't description does Spark itself doesn't know where heck which table to use. We can have multiple df table. We can have multiple virtual tables, right? We could have multiple. We could have multiple temporary temp views in a single app, right? So here I need to say from where? From df table, right? Again, so let's take a look now. Comma, I need comma here, right? I need comma. Right, looks okay. Let's take a look. Yeah, it works, and you can see, by the way, truncate is true, right? So it's truncating the data. Notice how truncate false. We don't see everything, so of course I would want to see. I'll do this truncate false, right? Truncate is false, right? Show everything. So instead, of course, this would be, you know. So truncate false is something which would be quite often we want to use. I'll do like maybe 2. Again, you'll see that this will show you everything, right? So again, here you could show, again, so if you need some extra columns, you basically use literal using the Spark syntax, or if you use SQL syntax, you just write what you need, basically, right? And it will figure out. Of course, you could rename something, right? Let's say as float 5, for example, right? This will be renamed, right? Let's do this, a more complex example. So not too hard, right? Oh yeah, I didn't need this, by the way. This is not needed, right? Because let's see, yes, so we can see everything, what it is, right? White hanging heart, tea light holder, white metal lantern, cream cupid hearts, coat hanger. Interesting, looks like heart-shaped coat hanger. Set 7 babushka nesting boxes. Oh yes, okay. So, very interesting things, items, right? And so now we know how to use literals, basically, right? So Booleans, next thing is Boolean, right? And so, again, of course, we know, and we can use them, as we know, we've been using Booleans all the time, right? we use them to build up true or false statements, right? So how do we do equality? You can use this. You can use equality like this in this syntax, right? And so let's take a look at this syntax here, right? So what it means is basically we say, okay, this ID, all rows which have an invoice number this. So select all rows which have invoice number equal to 536365, right? Okay. Let's run it. And of course, at the same time, well, before, to save time, we can also look at the SQL. So notice also there's a warning, right? Some particular, right? So you Spark, you use equality or this, right? If you use it, right, so using like this, it's also possible to use this syntax. And also, hopefully, we can use also regular. So we'll use this one, right? So there's three ways of doing it, right? Using this equal to method inside the column, by the way, right? We can use like this inside equality, right? So this is kind of weird, right? So maybe warning, right? Right. And also, of course, so all of these should be same, right? Right. So this third, and so lastly, we can use regular SQL again, right? So we'll use that. It's not covered here, but I will write it, right? Right. And there's Foursquare. Okay, there's another option, and hopefully, well, we have also we will have a regular SQL as well, right? Which is of course even better, probably the cleanest, right? So in string, right? So this will work in even also in Python if you ever encounter that, right? So this is third, right? Not lastly, and this is so we'll have 4 methods, right? We should have 4 methods, right? So this is most clean, right? Right. And finally, let's do if we can do Spark. So Spark SQL, and again don't touch. So select. Do we need everything? Yeah. Select all from df table. Right correctly. I hope I did. Where invoice number equals 536365, right? And again show. Yeah, and this is not need. This is an error right here. Show 5, false. Yeah. Okay. Let's see. So 4 ways of doing the same thing. Again, which one you prefer? I don't use this too much. Again, I use either. Well, I use this one quite a bit. Again, so these seem to me the simplest ones to use. Right? These two approach are, I think, the easiest ones. But again. Let's see, all of them, they should all theoretically return same number of data. Nothing is red. Okay. Yes, so 6686x6, yeah, 60, yeah, okay, looks like good. So again, these T-light holders, right? Okay, so 5365, cream cubit hearts hanger, right? And let's see, right. There's difference. So these were to select, we had only 2, right? Invoice description. Here I did everything, right? So of course I could change this to have only so I could do select here, right? I could do select this part. I forgot to put this here, right? So question is, can you put it here? Can you mix and match, right? Let's do that. So can you mix and match? Yes, you can. I'm pretty sure you can. So if this gives you an SQL, of course you could use it, right? If you want, this should also work. Let's see how our time is. I think we're almost done. Yeah, we are doing pretty good. So time for an exercise. So, but I like to. So you could do mix and match, right? So because this is what? This gives you a data frame, right? So you can do select like this, assuming you know these 2 columns, right? You can mix and match. So you can mix, you can mix and match SQL and Spark API, right? Like this. I'm pretty sure you can, right? And so again, I'll do show again, let's say 3, because I'm sure it's the same one, because I'm tired of, okay. Of course, as you can imagine, this is same as below SQL, right? Of course, as you can imagine, this is exactly the same. And in fact, I don't know why you would, again, why would you want to do this? Well, of course, if you have some queries you want to modify, sometimes often one of the ideas of Spark is you build these queries up, right? You try to do as little as possible in a single query. Here, of course, you could do this, right? This is exactly the same, right? As far as, again, Spark will figure this out. The engine will figure out how to do this, right? But in this case, right, I don't need this anymore, right? Okay, so these two should be same. Previous mix of SQL and Spark. Right, so let's take a look here. If this works, we can proceed to our exercise. Yeah, so my mix worked, you see. So this is mix, so this works. I mean, so you don't have to select. So this is all right. Speed-wise, there should be no difference. Even though you say you change your mind, you don't want all. You suddenly change your mind, and you want to have everything. Again, that's one of those things is that you narrow down the data you want. So this is, I mean, this is not that horrible actually. Again, speed-wise, this won't make a difference. Of course, if you already know what you need, right, then you can use this. But often, of course, you don't know exactly what you need, which columns you need. Maybe you'll get later. So yes, so we saw there's 4 ways of doing it. Match by. So what do I want from you? Okay. So to do is load 4th of December. Right? From we have it, right? Yeah, we have it. Yeah, no, sorry, that would be misleading. Let's do 7th of December. No, let's do, we have, I think, 11. Let's do 1st of March. Let's do 1st of March. Why not? Yeah, we do have it. Yeah, 1st of March. Let's load 1st of March of 2011, right? That's into data frame. Right, and then what do we want to do? What did we do before? We did limit, right? So we'll do that as well, right? Get, and let's take a look what's in there, right? What can we get there? What's interesting? And we can get, okay, so it's all United Kingdom? Well, so Finland, oh, there's Finland. Okay, great, there's Finland, that's good. Yeah, let's get Finland. Okay, so let's get Finland. Yeah. Get. So, get all purchases on that have been made from Finland, right? And then collect, but however, limit purchases to 20. And can we sort by something? I think we did this before, right? You can do this, right? Sort by unit price and limit 20. Again, it's up to you. You can use any, right? Sort by, and then collect results into a data into an array of rows, right? Print all rows. Print these 20 rows. Okay, so collect. Okay, so 4 things, right? Pretty easy. Sort by unit price and limit 20, right? What else do we know? Right, you can use, so note, You can use any, either SQL or Spark or mix of syntax, right? Right, so it's up to you, right? You can try different approaches. So Finland, so it should work, right? Again, I will be interested to see what kind of approach we take, right? And I'll see you tomorrow then at 10 o'clock. Thank you very much.